Yeah, good morning, students. In this particular session, we would like to discuss about the another important operation related to arrays, that is the search operation. Fine. So now I would like to share my screen. Hope my screen is visible to you. So this is the week 2 lecture 3 topic for discussion is binary search and comparison of both linear and binary search time complexities. So summary of the previous classroom discussion topic is that we discussed about the delete operation in arrays. So the deleting of an element can be done in three different cases. That is at the beginning of the array, and at the end of the array element you can delete it, or at a given index location also you can delete that elements from the array. So when you are performing the deletion, we need to move the elements or we need to shift the elements one step in the left direction of the array. We need to move that, fine. So that is the data movement is the another important that what we can call it as a disadvantage. You can say it as when you are performing this deletion or insertion operations in the arrays, fine. So that we discussed in the previous classroom. Now the current today's classroom discussion topic is binary search and the comparison of time complexities of both linear and binary search. So the objective of this lecture is that this session will develop the students' knowledge on binary search operation in array data structure and their time complexities. The outcome of this today's session is that after completion of this session, the student will able to develop the code to search for a given element in an array using the binary search technique and compare the time complexity of both the search techniques. Fine. So in the array, we have two different types of search methods are there. So search is one of the important operation we can perform in arrays. So the first method of search is called it as a linear search, which is also called it as a sequential search, we can call it as, and the second one is a binary search technique. So these are the two important methods which are used for searching for a given element in an array. So let us understand the working of this binary search. One of the important prerequisite for performing this binary search is that the given array of elements must be in the sorted order. Okay, the given array of elements must be in the sorted order. That is the prerequisite to apply this binary search. So whereas to perform this linear search, you need not require this sorted order array as an input. Fine. Now suppose we have an array of 10 elements are there. For example, in the 0th index to 9 index, these are the elements we have. So 10, 20, 30, 40, 50 like that. So we have 10 elements in the array. So which is indexed from location 0 to 9. So we want to search for an element 70. Whether this element 70 is there in the array or not, we want to search for this element 70 value. Fine. So here in binary search technique, what we will do here is that we will consider two variables so that left and right are the two variables. Initially, this left is assigned to 0th index location and right is assigned to the last location. Okay. And then we will calculate the mid index value. How we can calculate that? Left index plus right index by 2. If you do that, so you can calculate it as a mid index. So that is nothing but 0 plus 9. Okay, 0 plus 9. So left value is 0 plus right value is 9. So if you divide by 2, you are going to get it as a 4.5. So it is going to get actually the integer part only 4 we are going to get. So the mid value we are going to get it as a 4 and we want to see A of mid location. That means A of fourth location value is what? So 50. So now we will compare whether our required search element is 70. So is 70 is greater than A of mid location. A of mid location value is 50, isn't it? So if 70 is greater than 50, that is the data, the search data is greater than A of mid location, then your element may be present in the second half of this array. In this half, it will be there. So then what we'll do, we can ignore this particular half of the array, we can ignore that. This half of the array we can ignore. So that we can move this left index variable to mid plus 1 location. This is what we are calling it as a mid. Okay, into this mid plus 1 location, we will move this left. So left is pointing to this here. Again, the same process is repeated. So that again we will calculate the mid location, because here left is present at this. So left plus right divided by 2, we will do that. So 5 plus 9 divided by 2. So 14 by 2, that is nothing but 7. So now the new mid value becomes it as 7. Fine. So now we will compare whether this data present in this 7th the index location, that is 80. 80 is greater than 70 is greater than 80? No. That means, so if the 70 is present, it will be present within this half of the array. So within this half of the array, it will be present. Now we will ignore this half of the array. So like this process will be continued until the search is successful, or what we are saying is that until the low is lesser than or equal to high. Here low is nothing but left and high is nothing but right. So this is low is left. Fine. So low is nothing but the left index value, and high is nothing but the right, what we are taken in this particular exam. Fine. So as long as low is not crossing the high, that means low is lesser than equal to high, then we are calculating the mid. And if we are checking that if array of mid value is less than key, we are positioning the low to mid plus 1. Else if array of mid is equal to key, then search is successful, key element is found at the position mid location, then we will come out of this while loop. Otherwise, I will be moved such that it will be present in the another half of the array. So we are moving this high to mid minus 1 location. Fine. So this process is repeated as long as low is less than or equal to I. When low greater than high, then also there is no way of dividing that array into again halves. Then we will say that the key element is not found in the array. So this is what the program code for implementation of this binary search algorithm. Fine. So now coming to the time complexity of this binary search. So in this case, so we are calculating mid value, and then based on that we are calculating the comparing A of mid, and then what we are doing here is that first iteration length of the array we are taking it as n, and at the second iteration the length of the array we are dividing by 2, n by 2. In the third iteration the length of the array becomes it as n by 2 square. Therefore, after kth iteration, the length of the array becomes it as n by 2 power k, it becomes it as that. So, after kth iteration, the array length becomes it as 2 n by 2 power k. So, like that, after k iterations, the length of the array becomes ultimately 1. So, at the end, we are going to get it as length as 1 we are going to get. Fine. So, then what will happen here is that, so here what we are going to get the n by 2 power k, that if you are converting into a logarithmic value, so we are going to get the time complexity of the binary search is nothing but order of what we are calling it as order of log n is the time complexity we are going to get for this particular binary search algorithm. Fine. So this is what we are calling it as the binary search technique, and we can implement this binary search technique using any of this programming language. So we have to do that. And whereas for the linear search, the time complexity is big O of n. N is the total number of elements present in the array, because we are performing the sequential search, we are doing that. Fine. So the comparison between the linear search and binary search is that the first important difference is that when we want to apply the linear search, you need not require the input data in sorted order. Whereas if you want to apply this binary search, we require the input data should be in sorted order. The time complexity will be for linear search, it is order of n. For binary search, it is order of log n base 2. And the linear search is not suitable for large size data set. It is suitable for smaller data sets, whereas the binary search is best suitable for large data sets. Fine. So these are some of the comparisons between linear and binary search techniques. Okay. So this is what the summarization. So in the summarization, we discussed that the linear search and binary search are the two important search techniques that can be applied on arrays. Fine. So in the next class, you can refer to that the linear search technique also. Fine. So if you have any doubts, please ask the doubts here. So if you don't have any doubts, now I will stop the session today. Fine. So thank you. This is the lecture level practice problem that you have to solve within this today's class. Okay. So thank you. Thank you, one and all.